Good morning, students. Students, in the chapter which we have started, gravitation. In this chapter, students, we have studied what is gravitation concept, Newton's gravitational law, and we have find a formula for the force of attraction, gravitation. So first we would revise, then we would define weight, we would find the formula of weight, and finally we would find the relation between small g and capital G. So just revise what we have studied in brief. So we have seen that Newton told that every mass particle, I have told you that every mass particle, according to Newton's, every mass particle attract every another mass particles. Means if the particle, if there is two particles having mass, there is two particles, this is mass m1 and there is mass m2, then there would be definitely a force between them which is attractive in nature, and that force is called gravitational force. If the distance between their centers are r, then the force of attraction F is proportional to the product of their masses, that is m1 into m2, product of their masses, and the force is inversely proportional to the distance between, square of the distance between their centers. So this is the Newton's law of gravitation which we have talked, we have studied in the previous video lectures. So F is proportional to m1 m2, any product of masses, and F is proportional to 1 by r square. It means it is inversely proportional to square of the distance between their centers. So finally we can merge both of them, that is m1 m2 by r square. And as I have told you many times that when proportionality removes, there is a constant we have to introduce. So this constant is capital G here. This is m1 m2 by r square. Okay, the value of constant G is 6.67 10 to the power minus 11, and this is called universal gravitational constant. This is called universal gravitational constant. It means this is called universal gravitational constant. Universal gravitational constant. Why it is called universal? Universal means the value of G in this whole universe remains same, that is 6.67. Where you are in moon, whether you are in earth, the value of G would not change. That is called universal gravitational constant. That is why it is called universal gravitational constant. And the unit of G you can find from this formula. Just move this term r square here. So this is Newton, this is meter square upon this is kg square. So we can say kg to power minus 2. So this is the unit Newton meter square, kg to power minus 2. This is the unit of capital G. So just keep this unit in your mind, just keep this value capital G in your mind, and it is called universal gravitational constant. I have told you. Now in the today's video lecture we would talk about what is weight. What is weight? Actually weight of the object or weight of ourselves is the force of attraction which is applied by the earth. The force of attraction, that is gravitational force applied by the earth on the object by which it has its weight. So weight is what? Weight is, it is the force of, weight is, it is the force of attraction. It is the force of attraction. It is the force of attraction. It is the force of attraction applied by the earth. Applied by the earth on the object. So definition of weight. So weight is what? Weight is, it is the force of attraction applied by the earth on the object is called weight of the object. Is called weight of the object. Is called weight of the object. Weight of the object. This is called weight of the object. and weight is denoted by the symbol capital W. Weight is denoted by the symbol capital W, and the formula for weight is equal to, you have seen that in the Newton's second law there is a formula F is equal to ma. F equal to ma. You have seen in the Newton's second law the formula for force is F is equal to ma. M is mass of the object and a is the acceleration of the object. But we have seen here for the weight, acceleration is produced on the object. If you talk, suppose I have this chalk and I am holding this, it is not moving. I just put off my hand from the chalk, it goes down. So it start accelerating, its velocity continuously increasing. As I put off my hand from the chalk, its velocity start increasing and it goes down, and when it touches the ground, at that point the velocity would be maximum. It means there is a acceleration, but this acceleration is produced by the force. Which force? Gravitational force. Earth is attracting object from towards its center, that is due to its weight. Because weight is the force of attraction applied by the earth. So because of its weight, yeah, you can say because of the earth gravitational pull attraction, this shock is going towards the center of the earth, towards the downward. So the acceleration produced here for the weight is because of the earth. So F W equal to m into g. G is what? G is the acceleration due to gravity. G is small g. This is small g, this is capital G. Don't confuse on in between these two terms. Both are different. This is the universal gravitational constant, and G is what? Acceleration due to gravity. G is acceleration due to gravity. G is acceleration due to gravity. This is acceleration due to gravity. Okay. This G comes in picture when there is a motion, there is a acceleration because of earth gravitational pull. Okay. So the formula for weight, which is force, this formula is similar to this formula from the Newton's second law. F is equal to ma. This is W equal to m into, in place of a, it is acceleration due to gravity, that is g. So the formula for weight is W equal to m into g. Okay. Now what is the unit of this W? SI unit. What is the SI unit? You can find this very well because we have known the unit of force, SI unit of force is what? Newton. It is Newton. And weight is nothing but it is also the force. So the unit of weight is also Newton. This is the unit of force, also Newton in SI system, and in CGS system it is dyne. It is dyne, d by ne. In CGS system, CGS, the unit is dyne, d, y, and e. Okay. And there is a relation between 1 Newton equal to 10 to the power 5 dyne, which we have covered in the 4th chapter. 1 Newton is equal to 10 to the power 5 dyne. We have derived this particular relation in the 4th chapter. Okay. Now we would define some other units for the weight. There is gravitational unit of weight. What are the gravitational unit of weight? So the gravitational unit of weight are two. First one is kgf, second one is gf. There are two gravitational unit of weight. First one is kgf and second one is gf. What is kgf? This is kilogram force. Kgf is kilogram force. And what is gf? This is gram force. Okay. This is kilogram force and this is gram force. Now kgf is the unit is it is the gravitational unit, both are gravitational unit. It is in SI system, in SI system. This is in CGS system, okay. So kgf is the, what is kgf? Kgf is the gravitational unit of weight in SI system. gf is the gravitational unit of weight in CGS system. So there is a question related to these units, that what is the you can ask that you have to given a problem. So just we are going to find there is a relation between kgf and gf. Just find the relation between kgf and gf. What is kgf? Just define the kgf first. kgf, what is kgf? Just define it. We have known w equal to mg. We have formula w equal to mg. The value of g, we have not talked about the value of g. The value of g is approximately 9.8 meter. This is acceleration, so that's why this is ms minus 2. This is the unit for acceleration because this is acceleration due to gravity, and 9.8 is its value on the surface of the earth, yeah, just near the surface of the earth. Its value is 9.8 meter per second square. So when we talked about weight w equal to mg, this is kgf. So kg is 1 kg. If the object mass is 1 kg, if the mass of the object is 1 kg, so the force applied by the earth is called 1 kgf. What is 1 kgf? If the definition for 1 kgf, the force applied by the earth on the object of mass 1 kg is called 1 kgf. Okay, this is called 1 kgf. And what is 1 gf? Gf, the force applied by the earth on the object whose mass is 1 gram. Whose mass is 1 gram. The force applied by the earth on the object whose mass is 1 gram is called 1 gf. So there is a definition for 1 kgf and 1 gf. You have studied the force applied by the earth, weight of the object whose mass is 1 kg is called 1 kgf, and whose mass is 1 gram is called 1 gf. Now here you can see that mass is 1 kg into, if we put the value of g, that is 9.8. If we put the value of g, that is 9.8, the answer would be in Newton, that is 9.8 meter second minus 2. So the answer is 9.8 Newton, because the SI unit is this. So what is kgf? देखिए, अगर हम इसको g की वैल्यू को पुट कर देते हैं तो आंसर किस में आएगा आपका? न्यूटन में, बिकॉज kg मीटर सेकंड माइनस 2 क्या होता है? न्यूटन होता है. आपको पढ़ चुके हैं ऑलरेडी 4th चैप्टर में. लेकिन अगर हम लोग इसकी वैल्यू पुट नहीं करते g की, मतलब अगर हम इसको ये लिखते हैं सिर्फ 1 kg, सिर्फ 1 पुट करते हैं, m इक्वल टू 1 पुट करते हैं, तो ये आएगा 1g. क्या आ जाएगा? 1 इंटू जी. और इसको 1g को g की वैल्यू ना पुट करें, g को ऐसे ही रखा मैंने, तो ये जो 1 आपका आता है सिर्फ, तो यही आपका है 1 kgf. इसका मतलब क्या है कि ये जो 9.8 न्यूटन है, ये किसके इक्वल है? 1 kgf के, बिकॉज आई हैव टोल्ड यू द फोर्स ऑफ अट्रैक्शन बाय द अर्थ ऑन द ऑब्जेक्ट ऑफ मास 1 kg. अगर 1 kg का कोई ऑब्जेक्ट है, उस पर अर्थ जितना फोर्स लगाती है, या जो उसका जो वेट होता है, वही है 1 kgf. तो हमने सॉल्व कर लिया, किसके वैल्यू के इक्वल आया? 1 kg. 9.8 g की वैल्यू 9.8 न्यूटन, और यही 1 kgf है, यानी 1 kgf इक्वल टू आपका क्या हो गया? 9.8 न्यूटन. दिस इज द रिलेशन बिटवीन kgf एंड न्यूटन. व्हाट अबाउट gf? इसको देख लेते हैं. 1 gf, दिस इज w इक्वल टू mg. w की वैल्यू 1 ग्राम, तो ये ग्राम लिख देते हैं 1 ग्राम. g की वैल्यू ये मीटर में है, सेंटीमीटर में अगर आप बात करें सीजीएस सिस्टम में, सीजीएस सेंटीमीटर ग्राम सेकेंड, तो ये आपका सेंटीमीटर में जाएगा, तो 100 को मल्टी होगा तो 980 आ जाएगा. 980 सेंटीमीटर सेकेंड माइनस 2, तो 980 यहाँ पर पुट करेंगे 980, ठीक है. तो ये वैल्यू आ जाएगी आपकी 980 डाइन. क्या जाएगी? 980 डाइन. दिस इज द 980 डाइन. सो 1 gf ground force is equal to 980 dyne. This is the 980 dyne, 1 GF. Now, what is the relation between GF and KGF and GF? What is the relation between KGF and GF? Just solve it. So, for that, we have to convert this Newton into dyne. So, 1 Newton equal to 10 to the power 5 dyne. So, multiply by 10 to the power 5. So, it would come. So, this is very normal. 1 kgf, this is 1 GF. 1 kgf. kg is 10 to the power 3 gram. So, this is 10 to the power 3 gram force. So, this is the relation between kgf and gf. 1 kgf is equal to 10 to the power 3 gf. And you can also say that if we convert it in the dyne, so we have to multiply by 10 to the power 5, and this is 20, so this is 980 into 10 to the power 3 dyne. And you can say there is a difference of only 10 to the power 3. So 1 kg is equal to 10 to the power 3 gram force. So I think this is sufficient for today's video lecture. In the next video lecture we would solve for relation between G and G. So what we have studied? We have studied what is weight. Very important topic, weight. So weight is what? It is the force of attraction. It is the force of attraction applied by the earth on the object is called weight of the object. And the formula for the weight is just like the formula for the force, because weight is also force. And the formula for force according to Newton's second law, it is F is equal to ma. So in place of A we just put G, small g, because small g is what? It is acceleration but due to gravity. So this is acceleration due to gravity, and the value of G on the earth surface, near the earth surface, is 9.8 meters second power minus 2. So we have defined formula, we have defined this definition. The SI unit we have already known, it is force, Newton. The CJ unit, it is dyne. Now we have understand two other units which are gravitational unit of weight. So there are two gravitational units, kgf and gf. What is kgf? Kilogram force. What is gf? Gram force. What is kilogram force? The force applied by the object by the earth, the force of attraction applied by the on the object by the earth of mass 1 kg is called 1 kgf. The force of attraction applied by the earth on the object of mass 1 gram is called 1 gram force. And this kgf, gravitational unit of weight in kgf, is in SI system, and this unit in CJ system. Okay, because this is kilogram, this is gram. So this is in CJ system, this is in SI system. There is a relation 1 kgf and Newton. We have just solved. W equal to mg. M is 1 kg. G is 9.8 Newton. That is 1 kg of kitne Newton? 9.8 Newton. Similarly, W is equal to mg. M is equal to 1 gram. 980. So this is 980 dyne. So 1 gram force is equal to 980 dyne. And there is a relation between kgf and gf. 1 kgf is equal to 10 to the power 3 g. So all about today's video lecture. Thank you, students.